Hey viewers, welcome back to our channel. So today we are going to discuss another interesting question on the linked list, that is add to linked list. It is one of the frequently asked question in the interviews also. So let's try to figure out what is the problem statement. So in this question we are provided with two linked lists. It is 1, 2, 3 and 4. And the another linked list is 5 and 6. And we need to add them in such a way that I will get a new linked list. And the nodes of this linked list will contain the addition of the addition of the data of the nodes of the provided linked list. Means the 6 get added with this 4 and new node get created in a newly linked list. This 5 get added with this 3 and a new node get created in the newly linked list. As there is no more data in the second linked list, so this 2 will remain same and get added into the newly created linked list. Similarly, this 1 get added into the newly created linked list. So at last, we just need to return this linked list. So here you can see that we need to start our addition from the extreme position, not from the beginning. Means the 6 can only be get added with this 4 and 5 are not allowed to get added with this 1. Okay. The other thing about this question is that there might be a case that both of these linked lists will not be of the same size. As you can see here, that this linked list and this linked list are not of the same size, and there may be cases that when both of these will be of same size. So you need to tackle it very carefully. The third thing about this question is this: you are not allowed to manipulate the data of the linked list. Means you are not allowed to put the data in some other data structures and then perform addition, like you put all the data into the array or array list, and similarly you are not allowed to manipulate the data into the digit format and then perform addition. Okay. The third thing is that you are not allowed to reverse the linked list. Means you can't reverse the linked list and then perform addition. You just need to perform it. So just try to solve it by yourself. After that we will discuss that how we will approach to this problem. So I hope you have tried it by yourself. Let's try to understand the concept of this question. So what will be my approach for this problem is, I will use the same approach which I used in the reverse data recursive method. So what was that? It was nothing but I will recursively iterate over my provided linked list based on some condition. Why some condition? Just because here there may be a cases when both of the linked lists will be of different size. So one of the linked lists get added soon than the other. So I need to recursively iterate over both of these linked lists based on some condition, unless and until I will not reach to the extreme point. Means I will not encounter the base condition, and the moment I encounter the base condition I keep on backtracking. Means backtracking, and during the backtracking I will perform some task that will give me my desired output. Okay, let's try to understand it how it will work in the memory, what I'm saying right now. Okay, so we are provided with this stack. Means we are not obviously provided with this stack, but I'm creating this stack just to show you that how the recursion will work and how the linked list get manipulated during the recursion. So let me write here some let me write a two linked list here. So the first will be 1, 2, 3, 4. This will be our first linked list. This will be our second linked list. So what I'm going to do is that along with the head of both of this linked list, but I'm going to pass one more parameter for both of this linked list. That is nothing but the size of each linked list. Why I'm passing the size? Is because what I'm saying is that I will add only those nodes which are at the same level. Same level means I can say that this 4 node will be at level 1, this node will be at level 2, this 2 will be at level 3, and 1 will be at level 4. Similarly, 6 is at level 1 and 5 is at level 2. So what I'm saying is that this 6 can only be added with this 4. Means the 6 can only be added with that node which are at the same level. Similarly, 5 can only be added with that node which are at level 2, that is 3. So here you can see that with this we can achieve our result. So what I'm going to do is I'm going to pass the head of both of this linked list along with the sizes of both of this linked list. So here at the very beginning, what I'm going to pass, I'm passing 1 with the size 4. Similarly, 5 at the level 2. So as I can see that the node 1 and the node 1 of the linked list first and the node 2 of the linked list 2, that is 1, is not at the same level as of 5. So what I'll do, I will recursively iterate only over the first linked list. That is, I will iterate over only the first linked list. So this first linked list get updated only, that is, it called to its next, and now I reach here, this 2, and its level, the node 2 is at level 3, but my second, sorry, but my this, but my this, the second linked list node will remain at the same level. So it is at level 2. Okay, now I'm going to again check whether my current nodes are at same level or not. No, the 2 is at level 3, and the 5, node 5 is at level 2. So again I'm going to recursively call to my next level to the first linked list. That is, this 2 is going to call to its next node. That is, it calls this 3, and 3 is at level 2, and 5 will remain same. Now we compare that whether the nodes which are at the stack top are at same level or not. Now I can say that both of this linked list, both of these nodes are at same level. So what I'm going to do, I will recursively call both of these nodes to call to its next node. Means this 3 will call to its next node, that is 3 will call to the 4 and decrease and along with its level. Similarly 5 will call to its next, that it calls to its 6 at level 1. Similarly, they call to its next. So here is null, here is null. Now you can see that till now I reached to the base condition. From this base condition, I keep on backtracking, and during the backtracking, what I'm going to do, I keep on adding the values. The moment I encounter the base condition, here I'll return 0. What is the significance of this 0? This 0 will do nothing but will work as a carry, because each time I need to pass the carry. Just here, let me take some other case, like if we are provided with linked list like this 9999 and I need to add 1. So you can see that each time a carry get forwarded for its future nodes. So we need to pass this linked list, pass this carry for its future node. So here what I'm going to do, I am passing this 0 at, just because at the very beginning the carry will be nothing but 0. So here, as both of these nodes are at same level, I will add them. So 6 plus 4 I will get 10. I will extract out the modulo. I will do the modulo of this data to get the data, and I will divide the data to get the remainder, to get the carry. Okay, so I will forward out its carry into the for the future calls, for the future backtracking. So I'll pass that 1 to here, this 1 come here. So only I perform addition here, 5 plus 3 get added along with this carry. So here the value was 0, here the value will become 9, and here you can see the carry will be nothing but 0. So 0 will be forwarded, 5 plus 2 get. So here you can see that both of these nodes are at different level. So we don't do we don't perform addition. So here what we do, we add the 0 to this 2. So the node will remain 2. So again 0 will be forwarded, this 0 get added to this 1 and this, and here the new node will be created with the value data 1, and we keep on adding this node to our newly created linked list. Okay, let me write the code for this what I've explained right now, and after that we will try to examine that how this code will work. Okay, so we are going to write the code on the Pepcoding portal. So here the first thing I'm going to do is I'm going to recursively call to the another function. At first I will create a newly linked list. Okay, so I will create new linked list that will store the addition of the two linked lists. Okay, new linked list, and what I am going to do, I will call some another helper function So let me name it addLL, that will signify as add linked list. I'll pass one dot head to this linked list and one dot size to signifies the, and that signifies the level, that signifies the level of each node. Similarly, two dot head and two dot head and two dot size. Okay, let me create this function, public static int addLL. So here node 1 int level lvl level 1. Okay, similarly node 2 int level for second linked list. Now what I'm going to do, I will check if level 1 is greater than level 2. Then what I'm going to do, I will recursively call the function for the first linked list. That is, first linked list will call to its next node, one dot next and level its level along with its level. Its level, nothing will be one value less than the value it has. Okay, so but my second linked list will remain same, that will be nothing but 2 and level 2. Similarly, I will check that if my level 2 is greater than level 1. In that case, I will iterate only over the second linked list, means add linked list will remain same and second linked list will call to its next node along with its level, and its level will be nothing but one value less than the level it has. What the third case, that is if both the nodes are at same level. Now in that case, I need to recursively iterate over both of these linked lists. That is one dot next comma level 1 minus 1 and 2 dot next level 2 minus 1. Okay, now one more thing that you can see here is that this function is of return type. Now let me write the base condition. If 1 become null, means when I fully iterated over both of this linked list. 2 become null, what I'm going to do, I will return 0 in that case. As you can see, we are returning 0, means we need to store it somewhere. It is a carry, as I told you during the explanation part, that it is nothing but carry. So let me write it as an old carry. Okay, so here let me create a variable data. Okay, now what will be the data? So when during the back propagation time, as I told you, that we need to add both of these nodes at the current which reside at the top of the stack along with the carry which I get from during the back propagation. So what I'll do, I will one dot data plus two dot data plus old carry. Now from this, okay, let me write it outside of the loop. No, okay, it will remain here and OC. Okay, now the remaining code we will write outside all the if and else conditions. Okay, so we will update the new carry. The new carry will nothing but be data divided by 10. Similarly, I will okay, I have not passed the resultant linked list here. I need to pass it here and I'm returning it here. Return result. So linked list, let me take it here. Level 2 linked list, let me pass it here also. Let me pass it here also and here also. Res. So I'm going to add this node, means res dot add first. I'm going to add the addition of the data, but after extracting the carry cell. So I updated the carry. The addition will be nothing but data modulo 10. Now the third thing which I'm going to do is return what? Return new carry. Okay, so here you can see this is the case when I have both of the nodes are at same level, but at the case when both of these nodes at the different level, I need to manage them also. Okay, so here also I will create new carry as a variable, just because here also I'm getting some value from the function. So as I explained you in the case here, like what if my linked list is something like this, 9 9 9 9 and 1. So as I explained you that here the carry of 1 get forwarded throughout the throughout the backtracking. So here also we need to manage it efficiently. So what I'm going to do, I am taking it into the NC, that is new carry variable, and now my data will be nothing but 1.data plus this new carry. And after that I will perform the same work here also. Similarly, here also I will take the value from the return type, and the data will be nothing here but data 2.data plus new carry. Okay, so here everything is managed efficiently. The last thing which is left here is what okay, look at here. So as you can see here, this one get forwarded throughout the iteration of the linked list. So here will be 0, here will be 0, here will be 0, here will be 0. But here also one get forwarded, carry forwarded, and this get added at the very beginning of the linked list. Means what if this such type of case get arise? Means here also there might be a case that we get some carry. Let me take it, and if we get some carry like that, if NC is greater than 0, we do nothing, we just create a new node in the resultant linked list and add it to the beginning. So I hope you get it. Let's try to run it and then we figure it out how it is working. So we get a compilation error. It is saying cannot find symbol. That is LVL. Okay, let's see what we have written. We have LVL1 and LVL2, and we have passed LVL. Okay, it is LVL1 minus 1, LVL1, LVL2. Okay, let's try to run it again. Yeah, it is accepted. Let's try to submit it. Yeah, it is accepted. Okay, so here let me take this code. Okay, as we know that we are working on the function stack throughout the work, and okay, I'm taking an example of linked list like 1 2 3 4 5 and 6. It is at level 1, it is at level 2, it is at level 3, it is at level 4, it is at level 1, and this node is at level 2. So at the very beginning, what I'm going to do, I'm going to pass 1 with the level 4 and 5 with the level 2. So here I will check that whether both of the nodes are null. No, both of the nodes are not null. I will check that whether level 1 is greater than level 2. Yes, level 1, that is 4, is greater than level 2. So I will recursively call iterate over the first linked list only, that is 2 3, and this 5 will remain and same. So here again I will check whether both of the nodes are null or not. No, nodes are not null. I will check whether level 1 is greater than level 2. Yes, they are greater. So I will iterate over the first linked list only. These 3 get iterated over with its level, and 5 will remain same with 2. Now I will check whether both of the nodes are null. No, they are not null. I'll check whether level 1 is greater than level 2. No, whether level 2 is greater than level 1? No. So whether both of the nodes are at same level? Yes, both of the nodes are at same level. So I recursively iterate out both of these linked lists this time. So means 3 will call 4 at the level 3 and 5 will call, sorry, 3, 4, node 4 get called at level 1 and 5 will call 6 at level 1. Now again, as both of the nodes are same level, they again call them to their childs. That will be nothing but null. Here also it will be null. Now I come to know that here I get the base condition. From there I return 0, and let me remove it from the function stack. It get removed from the function stack. Now at that, so it is a forward. Let me remove it, forward iteration. Okay, so now during the back propagation, so at first this is the carry, these are the nodes, so I will add the nodes at the top of the stack. So this 4 get added with this 6, and along with this carry 0. Okay, so the sum will be 10. Now I need to extract out the new carry and need to extract out the data. So the new carry from here that is going to pass is 1, and a 0 node get added into the newly created linked list. So it also get deleted out from the top of the stack. Now as it is forwarded, this 3 get added with this 5 along with this 1. A new node get created along with the data, that is 9. Sorry, a new node get created. Okay, so from here the 0 carry is passed. It is also get removed from the top of the stack. Now as I can see that this condition will iterate, because from here we have recursively called ourselves. So from here only the node first linked list node or data get added with the carry. It means this 2 get added with the carry, so it will be 2 itself, and it get deleted from the top of stack. From here I'll also pass 0, and here also I think it was 1. Yeah, it was 1. Okay, so here also 1 get added with this 0, and it will be 1 itself. So at last I will check from here the 0 get returned to the other function, and there also I will check whether the carry that I'm getting from the helper function, whether it is greater than 0 or not. If it is 0, I'll just ignore it. Okay, if it is greater than 0, then just assume a case that I get 1 or 2 there, so I will create a new node and add it to the very beginning of the linked list. As it is 0, so I'll just ignore it and return this linked list. I hope you get the solution. So if you like this video, don't forget to hit the like button, subscribe the YouTube channel, and share it with your friends. Till then, stay safe, stay healthy.